This video is for predicted topics for paper 1, Edexcel IGCSE Chemistry Exam 2025, but this is for the people who do the 1CR or the original Edexcel. It's not for the 1C, it's for the 1CR. If you are doing the 1C exam, then there is another video. I will leave the link for that video in the comment section below. Please watch the other one. The content, however, is the same for both, but the exam is slightly different. So let's get started with this one. So I analyzed the type of questions that come in this exam over the past 5 years, and there's a specific trend for the questions that come. I will focus on the questions or the topics that are the most likely or that usually in every single exam. So the first topic is rate of reactions, the graph and the factor affecting reaction rate. You will always have a question related to this in your exam, one whole question. There is usually an experiment with some data for the rate of the reaction. So we need to understand how the graph changes with the changing in the factors. You should be able to calculate the rate of the reaction from the graph or the data provided. So if they ask you to calculate the rate at a certain time, then you need to draw the tangent at that specific time and then calculate the slope of the tangent. And then the different factors affecting the rate with explanation in terms of the collision. So they will always ask you in terms of collision theory, how can you explain the difference? How does this factor change in that factor affect the rate of the reaction? So you have always to refer to the collision theory. These factors are temperature, where increasing temperature increases the rate, and the concentration of the solution in case of solution. So if one of the reactants become more concentrated, then that means the rate of the reaction increases. In case of gases, if it's a gaseous reaction, then the increase in the pressure increases the rate, and also the surface area to volume ratio. If it increases, like if you use a powder rather than clumps of your reactant, then that will always also increase the rate of the reaction. And finally, the use of the catalyst. Remember that the catalyst will increase the rate of the reaction because it lowers the activation energy. It uses an alternative pathway for the reaction, or offer an alternative pathway for the reaction that has a lower activation energy, so it will increase the rate of the reaction. The catalyst itself will not be used up in the reaction. And the second topic that usually in the every single exam is energy change using calorimetry. So they're going to provide you with an experiment. It could be dissolving something in water or could be a certain reaction, and then going to ask you a few questions and to calculate the energy change. So there will be always an experiment, and note that for an experiment like the one you can see here, they will always ask you why did they use polystyrene cup, whether it's better than using a glass container or not. Of course, the polystyrene cup is better used because it's insulator, while the glass can transfer the heat to the atmosphere or to the surrounding. Why would you stir the mixture? Remember that stirring the mixture, maybe to dissolve the reactant if you are doing solubility, or it make sure that the reactants react together, and specifically also to ensure the even distribution of the temperature. And then the difference between the exothermic and endothermic reaction, because the reaction could be exothermic or endothermic. Remember that exothermic is this reaction when the heat is given off, and the endothermic when the heat is taken in. Meaning in exothermic, there will be a rise in temperature. In endothermic, there will be a decrease in the temperature at the end of the experiment. And then how to calculate the enthalpy change, because they will always ask you to calculate the enthalpy change for that particular reaction. Remember that we calculate the energy transferred first, which is Q, using the equation MC delta T, and delta T is the change in temperature. It's just whether it increases or decreases. This is just the difference, and the value here in joules. And then you need to calculate the delta H, which equals Q over N, and N here is the number of moles. So it's the value of the delta H will be in kilojoule per mole. Remember, if the reaction is exothermic, meaning if the temperature increased, then the value of delta H is going to be has a negative sign. So when you do your calculation, you have to add a negative sign to the final answer, because when you calculate the Q, it will always be in the positive sign. And then when you calculate the delta H here, if it's exothermic, if the reaction temperature increased, you have to add a negative sign to have the delta H in the negative sign. Also remember to convert the Q from joule to kilojoule because the delta H is kilojoule per mole. If the temperature decreases though, so it's an endothermic reaction, and then that means the delta H value will be in the positive sign, will have a positive sign. So in this case, you wouldn't add a negative sign when you do your calculation. Another topic that will always be in the exam, or I always see it in this exam, is the calculation of the percentage by volume of oxygen in air. So they're going to provide you with an experiment, ask you a few questions about this experiment. Why did they use this? Or what is the best apparatus to use? Things like that. And then they would ask you Ionic and covalent bonding is also one of the topics that will always be in the exam. So what do they like to ask about in this topic? The first one, they like to ask to describe what happens in the electronic configuration when an ionic compound is formed. So you need to refer to the loss of electrons for the metals and the gain of electrons for the non-metals, formation of the ions, and then the ratio between the metal and the non-metal in the ionic compound. They like to ask about the forces of attraction in a covalent bond. Remember, there is a difference between forces of attraction in a covalent bond, which is the electrostatic forces of attraction between the shared pair of electrons and the nuclei, and you have to say nuclei, not nucleus. And then there is the forces of attraction or between the molecules of the simple covalent structures or simple covalent molecules. So these are weak bonds, it's not strong bonds. It is different from the covalent bonds themselves. And when you try to melt the covalent structure or the covalent molecule, the simple one, you break these intermolecular forces of attraction, which are weak ones. They like to ask to complete a dot and cross diagram for a covalent, mainly for a covalent compound. So most of the time they give you the structure itself and they just ask you to complete the dot and cross diagram. Just make sure that you bought the correct number of the shared electrons. Explain the difference in the melting point. So this is very common in the exam. It could be explain the difference between ionic compounds and covalent compounds, simple covalent compound, or between giant covalent compounds and simple covalent structures or covalent compounds. So remember, ionic compounds, they have giant ionic lattice. There are strong electro forces of attraction between oppositely charged ions. They need a lot of energy to break these bonds, and so they would have high melting points. Simple covalent molecules, there are weak intermolecular forces of attraction between molecules. They don't need that much energy to break the bonds, so they have low melting boiling points. And then the giant covalent structure, they have covalent bonds all around the structure. Some of the molecules that are not in the specification and they like to ask about is the silicon oxide, so the silicon dioxide. So silicon dioxide is basically the sand, and this is a giant covalent molecule, giant covalent structure. So it has high melting points as well because there are covalent bonds all over the structure, and you need to break this covalent bond in order to melt it. The most chemistry, so there's usually only one question in the exam about organic chemistry. There isn't much of the content in the organic chemistry for paper one. This is for both the double award and the separate sciences. So what comes in the organic chemistry? Organic chemistry is for paper one is all about the hydrocarbons. So they like to ask you whether this structure is hydrocarbon or not, or define what is meant by hydrocarbon. Remember that hydrocarbons contain only carbon and hydrogen. So if they provide you with a structure that has any other atom in addition to the carbon and hydrogen, like oxygen, it's not a hydrocarbon because it contains something else other than carbon and hydrogen. Remember that alkanes are saturated hydrocarbon, meaning they don't have any double bond, they do not undergo addition reactions. While alkenes, they have double bond, and this is why they are unsaturated. So meaning of saturation, unsaturation means that there is a double bond and they can undergo addition reaction. Remember the addition of the bromine to the alkenes. So this is the bromine water test that distinguishes between alkanes and alkenes, or it's a test for the double bond. The observation for this test is that for if you have a double bond, then the bromine water change color from orange to colorless because the bromine has been added to the double bond. Sometimes they ask you to add a small molecule other than bromine to the double bond, like chlorine. So you have to be careful what they ask you about. So if they give you any small molecule with the double bond, you simply add it to the double bond. Substitution reaction of alkanes. So alkanes with bromine undergo substitution reaction. Remember the name of the reaction? It's called substitution. And the products will be bromoalkane and hydrogen bromide because they tend to ask you what is the other molecule given in this reaction. So it's hydrogen bromide. And the condition as well. So they usually, if they ask you about this reaction, they're going to ask you about the conditions. So the condition is the use of UV, and the products are bromoalkane and hydrogen bromide, and it's called substitution reaction. Homologous series sometimes in the exam, not always in the exam, so it's not very common to ask you about homologous series, but the main things that you need to know about homologous series that they are series of compounds that have the same general formula, they have the same functional group, so they have the same chemical properties, but they have gradual change in their physical properties. Isomers, it's not always in the exam as well, but the most important thing to know about isomers, because if it comes in the exam, they're going to ask you two things. First, I did to define what's an isomer. So what is isomers? So isomers are compounds which have the same molecular formula, but they have different structure formula. So this is the definition. And if so, they're gonna ask you to draw two isomers of a certain compound. So they give you a certain structure formula, a certain molecular formula of a compound, and ask you to draw two different isomers for that one. Remember the difference between empirical formula, structure formula, and displayed formula. There are always questions related to at least one of these in the exam. So we need to, and general formula as well. Sometimes they ask you to define what does this mean. Sometimes they ask you to draw or to determine the empirical formula or the structure formula or whatever, or to draw the displayed formula of a specific compound. And finally, addition polymers. So addition polymers will always be in the exam. I've always seen this question in the exam. Just be careful. It might be. Of course, when I say it will be in the exam, it doesn't mean that I know what the examiner is gonna put in the exam. They may change their mind, but based on the trend of the questions over the last 5 years, there's always a question about addition polymers. Addition polymers, it's the addition of the alkenes to make these long polymers. And then fuel and crude oil. So these are not in every single exam. They come periodically, but it's not in every single exam. So what do you need to know about this just in case it show up in the exam this year? So the fractional distillation of crude oil, they like to ask how did you get this fraction from the crude oil, or can you separate this particular fraction from the crude oil? They like to ask about the uses of the different fractions. So you need to know the name of the different fractions and their uses, not to lose marks if this question came up in the exam. And if they ask about fractional distillation, they're going to ask you about cracking. So cracking is when you break the long chain hydrocarbons to give the shorter chain hydrocarbons, which are more useful because we can use it as fuel, and also it gives alkenes, which can be used to make the polymers. They would ask you to complete an equation for cracking. So these questions are kind of related. So if one comes, the other will always come as well. And when they ask you about cracking, they're going to ask you about the catalyst. So you need to know the name of the catalyst and the temperature for the cracking. So the catalyst is either alumina or silica, and the temperature is 600, 700 degrees. Also the fuel combustion, so the complete and incomplete combustion. Sometimes they ask you to complete an equation for the complete or incomplete combustion. You need to know the different gases that are emitted when we burn the fuel. So the most important one they usually ask about is carbon monoxide for your exam. And this is because this is a poisonous gas and it's emitted when there is incomplete incomplete combustion, where incomplete combustion take place when there isn't enough oxygen when the fuel burn. So in case of the carbon monoxide, they tend to ask you about why is it poisonous. Remember that carbon monoxide will bind to the hemoglobin in the blood, displacing the oxygen. So the blood will not be able to distribute oxygen around the body. This is why it's poisonous, and it can cause suffocation. Remember the other gases emitted, it's not in every single exam. It's not very common, the other ones, but just you need to know them in case they decide to bring it up in the exam this year. So like carbon dioxide, it causes global warming because it's one of the greenhouse gases. We talked about carbon monoxide, and then the sulfur dioxide and nitrogen oxide. Remember, sulfur comes from the impurities of sulfur in the fuel, because there are some sulfur in fuel. So when you burn the fuel, the sulfur will burn as well to give you sulfur oxide. And then nitrogen comes from the very high heat of the car engine, where the nitrogen and oxygen in air can react together under this high temperature to give you the nitrogen oxides. Both sulfur oxides and nitrogen oxides are problematic because they can cause acid rain and respiratory problems. The main thing here is the acid rain. Qualitative analysis. So you need to, it's very common in the exam. There will be some qualitative analysis in the exam question. It became quite common lately that they give you like 6-mark questions with some ionic compounds and asking you to identify these ionic compounds based on the test you run. So you need to identify the ions in an unknown salt using the results of the test provided from the test, or sometimes they can ask you to plan an experiment to identify the different anions and cations in a provided compound. The most common ones that come in the exam are carbon dioxide, cations, and halides. So let's go very quickly over these tests to make sure that you know them all. So the first one is the test for hydrogen, where hydrogen gives a squeaky pop sound with lit splint, and then oxygen reignites glowing splint, chlorine bleaches litmus paper, and carbon dioxide turns lime water cloudy. Finally, there is the ammonia. The ammonia will turn litmus paper, the red litmus paper blue. And if you have ammonium ion, which is NH4 plus, then when you heat it with sodium hydroxide, ammonia will be emitted, and then you can test for ammonia with the red litmus paper. Test for metal, the flame test. Please make sure that you memorize the color of the different metals in the flame test. And sodium hydroxide test, we use it for only 3 different cations. Copper 2 plus will give you a blue precipitate with sodium hydroxide. Iron 2 plus will give you green precipitate, and iron 3 plus will give you brown precipitate. Finally, the test for the anions. The first one is the halides, which is the very, very common in your exam. So this is the silver nitrate. So use dilute nitric acid, or you can simply use acidified silver nitrate solution. If you have chloride, that will give you a white precipitate. If you have bromide in your compound, that will give you cream precipitate. And if you have iodide, that will give you yellow precipitate. A test for sulfate, this is with you add hydrochloric acid first and then you add barium chloride. So the test is barium chloride solution test. And if you have sulfate, that will give you a white precipitate. And finally, test for carbonate. So when you add dilute acid, carbon dioxide will be given off or produced. You can bubble this gas through lime water, and the lime water will turn cloudy. The math skills, so there will be a lot of calculations in paper 1. The most common type of questions in these is calculation of the AR, which is the relative atomic mass using the masses of different isotopes. So make sure that you know how to do this calculation. And then finding the empirical formula using the percentage composition of different elements in a compound. So practice these type of questions. You're going to find a lot of these in the past papers, and they are very common in the exam. The question that is always in the exam is to calculate the maximum amount that can be produced from a chemical reaction. So they provide you with a chemical reaction and they tell you that they use this amount from the reactant and calculate the maximum mass that can be produced from this reaction for a certain product. You have to look at the molar ratio in the balanced equation and calculate the number of moles and then convert the moles into mass. Calculation of the water of crystallization from provided data or from an experiment. Also, it comes in the exam, not in every single exam though, but you need to apply the same principle. So you always work with moles. So when you do your calculation, they can give you how much water was produced. You have to change that into moles in order to calculate the number of moles and to calculate the ratio. Calculate MR of a compound. Also, it's a very straightforward and easy type of question. So practice how to calculate the MR of any compound. Chromatography is very common as well in paper one for the 1CR or for the original one. So in chromatography, they could ask you to calculate the RF or how to set up an experiment or comment on the composition of a certain dye. So just look at the chromatogram they provide you with, and then you can comment on this one. Also very common in the exam is displacement reactions and redox. So displacement reactions of metals or for halides. So for metals, it's due to the difference in the reactivity. So this is related to reactivity series, where the metals which are more reactive or higher up in the reactivity series can displace the metals which are less reactive from their salts or from their oxides. And usually for these type of questions, they can ask you to provide the state sample for the reactants and products. So remember that when you add the metal, it's a solid, so the state symbol is S. The other one, the salt, is going to be aqueous, and then the new metal that is formed will be solid, and the metal which was solid that will form the salt, it's going to be aqueous. So remember these state symbols. And for the halides, it's from group 7. Sometimes they like to ask about group 7. It's not very common though in the exam, but you know that as we go down the group 7, the reactivity of the halogens decreases, which means the halogens which are higher up in the group 7 will be more reactive, can displace the other ones from their salts. So for something like chlorine, can displace either the bromine or the iodine from their salt. So a reaction between chlorine and potassium bromide or with potassium iodide can easily be can be done, and then you're gonna get potassium chloride and then bromine in case of bromide or iodine in case of iodide. So when they ask about these displacement reaction, they're going to ask you about redox. So oxidation reduction, remember oil rig, oxidation is loss of electron and reduction is gain of electron. So they're going to ask you why it is a redox reaction or which one was oxidized, which one was reduced. So you need to look at which one gained electron and which one lost electron. So it's redox reaction because there are loss and gain of electrons for reactants and products. And then there are these topics which are a bit common, but they are not in every exam. So first of all, the states of matter. So usually in this exam, the first question is a general question with one of these easy topics like the state of matter or maybe about diffusion or solutions. So this comes as the first question in the exam usually. So in the state of matter, they sometimes ask you to draw some molecules in a gas, or they could ask you what happens, what's the difference in the movement of particles between gases, so liquids and solids, and they like to ask about the name of the physical changes that leads to the change from gases to liquid and from liquid to solid, or from solid directly to the gas and vice versa. So make sure that you revise these because they may come up in the exam. Also, one of the very easy questions that comes up in the exam, not in every single exam though, it's the calculation of number of protons, neutrons, and electrons for certain provided elements or ions, and they will provide you with the mass number and atomic number. So when you do this, watch out for ions. So if there is an positively charged ion or negatively charged ions, the number of electrons will be different from the number of protons. Naming ionic compounds and formula of ionic compounds using provided ions as well. This type of question may come in the exam. So these three topics, they don't all come in the same exam, but one of them will be in the exam. They like to ask about these things and at the beginning of the exam. Alkali metals, which is group one metals, it does come in the exam. It's quite common. So you need to remember the reactivity trend in group one. As you go down, the reactivity increases. So they like to ask about observation for the reactions, especially the reactions of alkali metals or alkali reactions of metals. So just revise group one and their reactions and the different observations you see. Rusting, not very common though in the exam. It comes so over the last 5 years, maybe it came twice or three times. Remember that there are two different exams per year for this, for the Edexcel. But the things that they like to ask about in rusting is to name the rusting product, which is hydrated iron-3 oxide. How to prevent rusting or describe the Atherton method, which is the use of barriers, and the galvanizing using zinc. And also, they like to ask about the different conditions needed for rusting to occur, which is the presence of oxygen and water as well. It's not just oxygen, it has to be oxygen and water. Making salts, not very common in the exam, but it comes in the exam. So there are two different types of making salts. You can make soluble salts from an insoluble base and an acid, and then you can make the insoluble salt from two soluble salts, so like displacement reaction. For making salts, you need to sometimes they ask you like 6 mark questions. Describe the method how to make this soluble salt. So just make sure that you know how to the method how to. Separation of component of a mixture, at least one of these will be in the exam, so not all of them. So remember that filtration, we use it when we separate insoluble solid from a liquid, and crystallization is used when the solid is dissolved in the liquid, so when it's a soluble solid. And if you want the liquid, not a solid, you would use simple distillation, and if you have a mixture of liquids, you would use fractional distillation. And of course, chromatography, it will separate the component of dyes. Acid bases and alkalis, they come up in the exam from time to time. What is the most important things that you need to know about acid bases and alkali that will come up in the exam is the pH scale. So they like to ask you, this is a weak acid, which what do you expect the pH to be? It's like multiple choice. So if it's a strong acid, the pH will be like 1 or 2. If it's a weak acid, you would expect it to be like 5, 4, 5, or 6. If it's a weak base, expect it to be something like 9 or maybe 8, 9, 10 maximum. But if it's a strong base, it's usually 13 or 14, maybe 12. So these are the pH scales for the different acids and bases. And then universal indicators, so they like to ask what do you expect the color of the universal indicator at a certain pH. So make sure that you remember the use of the universal indicators. And the color of indicators in acidic and alkaline solution, like litmus, so it's red in acidic solution and blue in alkaline, phenolphthalein, colorless in acidic, and pink in alkaline, and so on. The metal, remember that metal oxides are basic and non-metal oxides are acidic. So if you dissolve metal oxides in water, then the pH will be high and the color of the indicator will give you the alkaline pH. If you have non-metal oxide and you react it with water, they're going to be acidic, like sulfur dioxide, for example. So the in this case, it's going to be acidic, and the pH of this the solution is going to be in the acid range. Finally, there are certain common types of questions. So, like they can ask you to name the apparatus. So, they could ask you, can you name this apparatus that is used in this experiment? Or they could give you figures which have these certain apparatus and ask you to name them. So, just make sure that you know the names. How to improve a specific method to make sure that you have completed the reaction. So most of the time, it's just you need to repeat the experiments many times, weigh the mass or find the mass of the product and make sure that you get to the point where the mass doesn't change. Most of the time, this is how to improve the method. Give a chemical equation for a certain reaction, very common as well, where they tell you that this is a reactant and this what happens, and this reactant will give you these products. So write the chemical equation for this reaction. Safety in the lab as well. So sometimes they ask you how to make sure that this is safe, or what do we need to do to ensure safety in the lab. And finally, one last thing that comes up in the exam as well is the thermal decomposition of the carbonate. So this comes up a lot in the paper one exam for this type of exam. So make sure that you understand and know the name of thermal decomposition, because they like to ask you, what is this reaction? What is it called?